Here's an example that's slightly different to what we've encountered so far. You notice that on the bottom it's already factorised, and that we've, as well as getting an x minus 1 and x plus 1, we've got an x plus 1 squared. Now, there is a technique for coping with the fact that when we've got one of the factors that actually has a power other than 1. They're not all linear factors. Power 1 there, but we've got power 2 there. So the way to do that is to split it into partial fractions, but we use a slightly different approach. We've still got a over x minus 1, because x minus 1 will be one of the partial fractions. X plus 1 is another one of the partial fractions. But the third part, there's going to be 3 partial fractions, and the third one will be x plus 1 squared. And there'll be a c value there. So this is slightly different. If it was only just x plus 1 to the power of 1, we wouldn't have to worry about that one. But if we've got it to the power of 2, we have to find a third partial fraction. The technique from there is the same as what we've been doing before. We've got to find values for a, b and c. And then when we do the integral of that, we can do the integral of each of the 3 partial fractions individually. I'll just get you through the first little bit here. And we've got to make all the denominators the same before we can add them to get that. So this partial fraction here with a denominator of x minus 1 has got to be multiplied by top and bottom by x plus 1 all squared. So it'll be a over x minus 1 top and bottom by x plus 1 all squared, plus b over x plus 1. Okay, what have we got to multiply x plus 1 by to get all of that? It'll be x minus 1 x plus 1. And whatever we do to the denominator, we've got to go to the numerator. And c at the moment has got x plus 1 all squared. We want to make it into the same denominator as that, so we're going to multiply top and bottom by x minus 1. Alright, that's got all our denominators the same. With that there will be x plus 1 squared and x minus 1, x plus 1 squared, x minus 1, x plus 1 squared. So they can all be combined into one. And it can be written all over x minus 1, x plus 1 squared. It'll be a outside of x plus 1 squared plus b outside of x minus 1, x plus 1, and then plus c, x minus 1. So what we can do is to multiply out, and we can, well, before we do that actually, we could actually equate the numerators. Alright, so we've got the denominators are the same. So therefore we can say that x squared plus 2x plus 3 has got to be equal to a x plus 1 squared plus b x minus 1 x plus 1 plus c outside of x minus 1. And just as we've done before, by letting x be certain values, we can eliminate one of the a's, the b's or the c's. So if we let x equals 1, that will make that term all equal to 0, because 1 minus 1 is 0, it doesn't matter what that is, 0 times anything is 0, and it'll also make that equal to 0. So we get 1 squared, substituting in here, plus 2 times 1 plus 3 is equal to 1 plus 1 squared is 4, so 2 squared 4, 4a. And as I said, this is equal to 0 and this is equal to 0. And 1 squared is 1 plus 2 plus 3 is all equal to 6, so 6 is equal to 4a. So a is equal to 6 on 4, which is equal to 3 over 2. So that's got our a value. Now we've got to get a b value. Now to get, or get a c value, if we make x equals -1, that'll get rid of, that'll make that equal to 0, and that'll make that equal to 0, and that'll give me a c. So x equals -1, so substituting in here, we've got -1 squared, that's 2 -1 plus 3 is equal to, now x equals -1, we'll make that all equal to 0, so that's going to make that all 0. It'll make that equal to 0, so it doesn't matter what that is, everything there will be now 0, and that'll be equal to c outside of -1, take 1. So what's this equal to? That's +1 plus 3 is 4, 4 minus 2 is actually equal to 2. That's equal to -1, take 1 is -2c. So divide both sides by -2 and you get c equals -1. So we've got a is 3 on 2, c is equal to -1. To get b, there's no other substitution that springs to mind that's going to make both a and c equal to 0, because you've got x plus 1 there, you've got x minus 1 there, because we want to be left with b, no can do. So the technique is basically just to let x be any value, and then we'll be able to do a substitution for a and c and hopefully come up with a value for b. And pick something that's easy. So if we let x equals 0, that makes this very easy to evaluate, because we've got 0, 0 plus 3, so that's 3 equals. Now x equals 0, we've got 0 plus 1, so we've just got a. X equals 0, we've got -1, so times +1, so -b. And x equals 0, we've got -c. Okay, 3 unknowns, and we've got one equation, but we haven't got 3 unknowns because we've got a value for a and we've got a value for c. So we've got 3 equals, a is equal to 3 on 2, minus b, and minus c, minus becomes a plus, so that'll be +1. So if we get b over to this side, 3 comes over to there, we get 3 on 2 plus 1 minus 3, which is equal to 2.5 minus 3, so we get 2.5 minus 3 is -1/2. So b is equal to -1/2. So we've got a is equal to 3 on 2, b is equal to -1/2, and c is equal to -1. Alright, so we've got values for a, b and c. So now we can do our integration. So the integral of x squared plus 2x plus 3 over x minus 1, x plus 1 squared dx. So that was the original question that was asked. We were able to split that fraction there into its individual parts, so I'll just substitute in for a, b and c and do the integral of each of those. So the integral of all of that will be the integral of each of those. So it'll be the integral of over x minus 1, whatever our a value was, and a is equal to 3 on 2 dx, plus the integral b over x plus 1, b was equal to -1/2 over x plus 1 dx, plus the integral c over x plus 1 squared, so c was equal to -1 over x plus 1 squared dx. So we've got 3 integrations there to do. That one's just going to be, if you let u equals x minus 1, you just get ln u, and it would be ln x minus 1 with the factor 3 on 2 at the front. This one is a similar one. It'll be just negative a half ln x plus 1. This one here might be a little bit more attention needed here. So we can take the negative 1 out the front, and then we've got to find the integral. So we've got minus the integral of, now, x plus 1 to the power of 2 as a denominator will be the integral of x plus 1 to the negative 2 dx. So the minus from this negative 1 has come out the front. X plus 1, instead of writing it like a fraction like that, we write to the power of negative 2. And the rule is, because it's just an x, it's an x plus 1 there. We've got add a power on the power, so that'll be minus x plus 1 to the power of negative 1, and then over negative 1. Add a power on the power. That negative 1 divided by negative 1 makes that into a positive. So we will get the integral of this will be 3 on 2 ln of x minus 1 plus, oops, we've got a minus there. So that'll be minus a half ln of x plus 1. And now we've just worked out that the integral, this integral here, that minus makes that into a plus. Now, x plus 1 to the negative 1 is 1 over x plus 1. And then we've got a constant of integration, which we'll just call c. Okay, so that's quite a little bit more complicated. Let's go back and have a look again. When you've got a repeat factor, so we've got x minus 1 and x plus 1, but we've also got x plus 1 squared. So the idea with this is, when you're splitting it into partial fractions, is to go x minus 1, x plus 1 is linear, and then if this is to the power of 2, you've got to do 1 to the power of 2, so we'll have 3. Same sort of technique. We actually get the denominators the same. We equate the numerators from both sides, so the numerator there, the numerator there, we equate them. We search for values of x that'll make some of these terms into 0, which allows us to be left with one of them. So x equals 1, made both of those 0, etc. And then to get the third one, it was not possible to find any more values of x that will make them equal to 0. So just pick x equals 0. We've already used 1 minus 1. You could have used x equals 2 here, and you would have been able to solve and come up with the value of b as well. So that's got our 3 numerators for our partial fractions, and then so you do the integral, you split it into the integral of each of the individual partial fractions, and be very careful when you've got something like this. These x minus 1s and x plus 1s are just ln's, but this one here is add a power on the power rule, and we came up with just a term of 1 over x plus 1. And don't forget your constant of integration.